In this video, we're going to be using the quadratic formula to solve quadratic equations. So as a little reminder, the quadratic formula is x equals the negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we go to solve, we want to make sure that we have it written in standard form first. So we have a, b, c. So notice here we have our a value and our b value and our c value all on the same side, and it's set equal to 0. So the first thing that you want to do is you want to indicate what is your a value, what is your b value, and what is your c value. So here we have 3, 2, and negative 10. Then we're going to plug them in. When I plug them in, what I prefer to do is to put all of my parentheses where they're going to go first. You are more than welcome to put them in as you go. This is just what I like to do. So that's a B, that's a B, this is an A, and this is a C. So when I put in my numbers, I'm going to have the opposite of 2, and this should be a 2 squared, and then a 3, and a negative 10, and then a 3. So from here, what we're going to want to do is we're going to want to take just this inside piece right here and plug that into the calculator. So we want to plug in what is 2 squared minus 4 times 3 times negative 10. And when we do that, we're going to get the value 124. From here, we are now going to continue. So negative 2 plus or minus the square root of 124 over 6. Now we need to break down that 124. So now we're going to take our square root, right? We're going to take this piece right here, the square root of 124, and we're going to break it down right here. So 124. So what numbers will go into 124? Well, 2 is an easy one, so 2 and 62. Now 62 will also break down with the number 2. So if you wanted to, you could stick with 2's the whole way. Now the number 31 is a prime number. And so we can rewrite this now as x equals negative 2 plus or minus. Now if we look at those pairs, we have a pair of 2's, so 1, 2 will come out. That 31's left over 6. Now, depending on what your teacher wants, they might let you leave it like that. But because the 2, and the 6 all have a number in common, you might need to reduce that. So that could turn this into a negative 1 plus or minus a 1 times the square root of 31 all over 3. And you wouldn't necessarily need the second one right here because we don't usually put a 1 out in front of things. And so that would be my answer. Right? Of course, you'd have to write x equals as well. Maybe I'll fix that really fast. So x equals, there we go. Now this is something that you could also plug into your calculator, and you could get the decimal equivalent of this to be able to check it as well. Let's do the quadratic formula with letter B. So here we have 3x squared minus 6x plus 3 equals 0. We see that it's written in standard form. And so now we're going to find what is our A, what is our B, and what is our C. So we have an A value of 3, a B value of negative 6, and a C value of 3. So this time when I plug it in, I'll go ahead and I'll put them in as I go, in case that's what you'd like to do, so you can see that as well. So I have a negative 6 plus or minus the square root of negative 6 squared plus 4 times 3 times, oh, it looks like I made my c the wrong color. Let's try that again. There we go. Times the c of 3 all over 2 times a, right? Then we want to take this inside piece right there, and we want to know, when we plug that into the calculator, what does that give us? So in the calculator, we're going to type in -6 squared plus 4 times 3 times 3. And we should get a value of 72. So now we go to rewrite, and we have x equals 6 plus or minus the square root of 72 all over 6. And now we're going to take that square root of 72 and we're going to break that apart because it's not a perfect square. So 72 is divisible by 9. So I'll use a 9. So I'll go 9 and 8. 9 breaks down with a 3 and a 3. 8 breaks down with a 2 and a 4. And the 4 breaks down with a 2 and a 2. So we're again ready to rewrite this. So we have x equals 6 plus or minus. We have a pair of 3's and a pair of 2's and then 2 left over. So that's going to be a 6 radical 2. So we'll put our 6 radical 2 in that spot all over 6. And then here we see that our 6 and that 6 all have a 6 in common. So we can reduce this to x equals 1 plus or minus the square root of 2 over 1. And we don't write over 1. And so this would be my solution. And again, I could plug that into my calculator and get decimal equivalents if I needed to be able to check it, or if I was trying to graph something. So looking back on this, I see a slight error that we have here, because on the inside I have written -6 squared, and then I put a plus, but that's supposed to be a minus. So if we go back and change that to a minus, how does that change our value? And it changes our value because now we no longer have a 72 here. We have the number 0. So notice how making a small change and not paying attention to how you're supposed to write the quadratic formula can make a big impact on your solution, because now we should have here the square root of 0. And the square root of 0 is 0. So we have 6 over 6, which is a 1. So here our answer is 1. So we'll have a repeated solution. Mistakenly putting a plus sign in front of the 4 like that is a pretty common error. So make sure that you're paying attention, because 1 plus or minus radical 2 is a big difference than just a 1 as far as solutions go. Let's do one more together. So here we have x squared minus 2x plus 2. It's written in standard form already. So we want to know, what is our a, what is our b, and what is our c? On second thought, this might be a great opportunity for you to try this on your own and see if you get the correct answer. So go ahead and pause the video, work out the problem, and then when you're done, push play, and let's see if you are correct. So we have an a value of 1, a b value of -2, and a c value of 2. So now we're going to go ahead and plug it in. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we'll plug in our pieces. So we have our b, the a's, and our c. We're going to take the interior of our radical and we're going to work that out and get the value -4. So when we rewrite this, now we have x equals 2 plus or minus the square root of -4 over 2. And we know that the square root of -4 is going to be a 2i. right? So the square root of negative 4 equals 2i. So we can plug that in. So now we have x equals 2 plus or minus 2i over 2. And we notice that those numbers all have something in common. So we can again write it as x equals a 1 plus or minus I over 1, but we don't really write that. And so x plus or minus I, so 1 plus or minus I, will be our solution. So here we have an imaginary solution, which means that when we graph it, our graph kind of hovers. It doesn't really cross that x-axis. Whereas on part B, it's going to touch in one spot. And for part A, it's going to cross it in 2 places.